Hello friends, welcome back to the channel. So today we are going to talk about one of the most important components in Kubernetes, that is Kubernetes Services. Well, in our last session, we already discussed how we use a deployment to deploy and manage our pods. But just deploying pods isn't enough, right? For every deployment, we generally create a service to enable communication between different components, both inside the cluster and outside the cluster. So today, let's understand why we even need a service in Kubernetes. And more importantly, what happens if Kubernetes had no service at all. Let's walk you through a simple scenario, Kubernetes without services. So we know we deploy a pod using deployment in Kubernetes. The deployment then creates a replica set, which is a controller and responsible for maintaining the desired number of pods. So if we set the replica count to 2, it creates 2 pods. Similarly, if we set it to 3, it creates 3 pods. Simple. Now suppose we want 3 replicas, pod 1, pod 2 and pod 3 in a worker node. And we already know why we need multiple replicas to achieve high availability. Imagine 100 users trying to access your application and you only have one pod serving all the traffic. That single pod will easily get overloaded and can even crash. That's why we run multiple replicas of same application. Also, each replica or each pod gets its own unique IP address. For example, pod 1 is getting 10.244.1.247 and pod 2 is 248 and pod 3 is 249 in a single worker node. So kubeproxy programs the network rules so traffic can reach the correct pod IPs inside the cluster. Now let's imagine this scenario without a Kubernetes service, just raw pods. Suppose we have 3 pods and somehow users are directly hitting the pod IPs through the DNS name, that is solution.sch.buzz. So imagine 10 users are getting response from pod 1, 10 users are hitting pod 2 and 10 users are getting response from pod 3. And this DNS is somehow pointing directly to each pod's IP. Now here comes the problem. If any one pod goes down, maybe due to the resource issue, network issue or anything like out of memory killed, CPU memory pressure, liveness readiness, prop failure, crash loop backoff or anything, Kubernetes will definitely try to heal the system because with the deployment we get auto healing behavior. We know pods are ephemeral. They behave just like containers. They are created, destroyed, recreated. And the component responsible for this healing is replica set controller. The replica set's job is simple. Make sure the desired number of pods are always running. So the moment pod dies, the replica set creates a new replacement pod. But here is a big issue in this no service scenario. The new pod will always come up with a new IP. For example, earlier the pod IP was 10.244.1.247. After restarting, the new pod might have 10.244.1.250. Now think about it. Those 10 users who were accessing pod 1 using its old IP will suddenly get service unavailable or application not reachable because their traffic is still going to the old IP which no longer exists. So this makes one thing very clear. We cannot rely on pod IPs to access the application in Kubernetes. So what's the solution? So instead of using pod IPs, we access our application through a service IP address. So a service in Kubernetes provides automatic load balancing across pods, smooth handling of pod restarts and IP changes. So first major reason why we use services to achieve load balancing and a stable network access in Kubernetes. So now we have understood that on the top of deployment, we use a service. The service provides load balancing and helps distribute traffic evenly across all the pods. Internally, it uses kubeproxy to route traffic to the correct pods. So I will explain the Kubernetes service networking part in the separate session. Now the next important question is, how does a service actually access pods? The answer is service discovery. Instead of managing pods using their IP addresses, Kubernetes services work using labels and selectors. Let's understand this step by step. We create a deployment using a YAML manifest file. Inside the metadata section of the deployment, we define labels. For example, app is equal to SEH solutions. A label is nothing but a tag attached to a source. Now this deployment will create a replica set. Let's say In the deployment, we mentioned replicas is equal to 3. So the replica set will create 3 pods, and all of 3 pods will automatically have the same label, which is app is equal to SEH solutions. What happens when pod restarts? If any pod goes down and gets restarted, its IP address will change. But according to the deployment YAML, the pod must always be created with the same label. So even if a pod goes down multiple times and comes back again and again, it will always come up with the same label. This is extremely important. Now, to connect these pods with the service, we use something called a selector in the service manifest. In the service YAML file, we define selector as app is equal to HA solutions. So the selector in the service is basically matching the labels in the deployment. You can think of it like labels identify pods, selectors search for these pods. The service does not care about pod IPs. Instead, the service keeps track of labels. Whenever new pods are created, the service uses its selectors to continuously look for pods with matching labels. As soon as it finds them, it automatically adds them as endpoints. I will explain this clearly in a live demo. So, when a service is created, it looks for all pods that match the selector labels. In our case, it finds 3 pods and registers all of them as endpoints. After that, any request coming from an external user or any other application inside the cluster is automatically forwarded to one of these pods. So, for now we understood 2 advantages of using service. One is load balancing and another one is service discovery. Now, how do we expose our application to the external world? The answer is by using Kubernetes service. So this is the third and very important use case of a service. It exposes our application to the external world. Let's understand this with a simple example. We deployed a pod that has a web application running inside it. Now the question is, how do we, as an external user, access that web page? Let's look at the existing setup. The Kubernetes node has an IP address, for example 192.168.0.1. The internal pod network range is 10.244.1.0/24 because we are using Flannel as the CNI plugin. The pod running our web application got an IP address that is 10.244.1.248. Now clearly, from our laptop or any external system, we cannot directly ping or access the pod at 10.244.1.248 because it belongs to a separate internal network. So what are the options without a service? One option is open the firewall to Kubernetes cluster, SSH into the Kubernetes node at 192.168.0.1. From inside the node, access the pod either using curl or a browser. So in this approach, first we SSH into the node, then from the node we access the application running inside the pod. But this is not practical. What we actually want is to access the application directly from our laptop without doing SSH into the Kubernetes node just by hitting the node's IP address. So clearly, we need something in middle that can receive requests from our laptop on the node and forward those requests to the pod running the web container. And this is exactly where a Kubernetes service comes into play. A Kubernetes service is an object just like pods, replica sets, deployments. One of the key use cases of a service is it listens on a port on the node that forward incoming request to a port on the pod where the application is running. This allows external users to access applications running inside the Kubernetes cluster in a clean and a controlled way. So today, we understood what a Kubernetes service is and why we actually need a service in Kubernetes. In the next lecture, we will look at the different types of Kubernetes services and when to use each one. If you really found this helpful, don't forget to hit like, subscribe and share this video with your friends. See you in the next session. Happy learning!